countdown clock continuing in 4 seconds and counting. This is shuttle launch control.
Was born and raised in downtown Detroit in Lafayette Park, which is just across the freeway from Greektown and now Ford Field and that area. There's Chrysler Elementary School in Lafayette Park was very formative, had several really inspirational teachers. Mr. Navarre was my science teacher, third grade teacher, and so I knew then that I wanted to be a scientist. I went to Cass Technical High School and did pretty well. I ended up leaving the state after graduation and going to the University of Alaska Fairbanks for adventure and outdoors, and discovered the Aurora Borealis. And also discovered through undergraduate research experience the entire field of space physics, that there are people who are studying the northern lights and how the sun influences the space environment. And so from a lot of technical, this was pre-computer, and so the magnetometers, the instruments that measure variations in the Earth's magnetic field, essentially were on a paper roller that had a little ink pen that sat on it, and the drum spun once a day. And so whenever the Earth's field wiggled, it would draw on the paper, and somebody would have to come and put a new piece of paper in every day. And so you had a daily magnetogram. And one of my first projects was to digitize these magnetograms for one of my undergraduate advisors, Shin Akasofu. And Professor Akasofu is famous for his seminal work understanding auroral substorms, or essentially the brightening of the aurora. So that got me going. I met a woman in freshman orientation, Patty Hogan, and we're still together, so I guess 38 years, and 2 children. But she went to high school in Alaska, and so wanted to leave and go to a big city. So we ended up at Boston University for my PhD. And still sort of naive, knew I wanted to teach. Patty became a kindergarten teacher, and so I knew that I wanted to teach, but I wanted to teach adults. And so just pursued becoming a professor. And after 2 years of a postdoc at Los Alamos National Lab in northern New Mexico, ended up at a small school in the east coast of Florida, Florida Institute of Technology, and was there for 5 years. And that's where our kids were born, but we moved to Los Angeles, and I became a professor at UCLA. And all of our family are in Northeast Ohio and Michigan. So when I was called by a colleague here at U of M to if I was interested in applying for a faculty position here, we jumped at it, and it worked out. So we've been here for 12 years. And went to Boston University in their astronomy department. So I knew I always loved space science, had a telescope when I was little. And that's when I really needed to develop a research area. And you can sort of think about space science as often divided up into sort of 2 major components: astrophysics, and that usually studies everything outside the solar system, and space physics studies everything inside the solar system. And one of the advantages of space physics is that we get to go to what we're studying. We can build robots and satellites and rovers and answer questions. So if you did, I wonder what's on the far side of the moon, let's go. Or I wonder what's on the surface of Titan, one of the moons of Saturn. You can build instruments to do that. So I became a space physicist and analyzed magnetometer data on a spacecraft that was orbiting in the very distant reaches of the Earth's magnetosphere for my PhD. And then at Los Alamos, I was introduced to a different type of instrument, a plasma analyzer, electrostatic analyzer on geosynchronous satellites. So one of the reasons why a nuclear weapons lab has space physicists is that during the 60s, after a number of atomic and nuclear weapons tests on the surface and in the atmosphere, and even at higher altitude, everyone realized the impact that these tests had on technology and sort of some of the first space weather events. There was a test in the far Pacific in Honolulu, 1,400 kilometers away, had all of their streetlights go out, which was one of the indications that a nuclear weapon blast in the atmosphere or in space can cause issues. And it also essentially destroyed all the orbiting satellites. And so there was a concerted effort between the Soviet Union and the US to develop test ban treaties. And part of those test ban treaties was developing ways to actually verify that each side is upholding their bargain. And the Department of Energy, which had the nuclear weapons lab, were also charged with those test verification, treaty verification. And so a whole series of satellites were launched to do this, as well as ground-based instruments. And one of the interesting aspects of space weather is that a lot of the natural space environment is essentially very similar to nuclear weapons blast, a lot of high energy particles and radiation. And so you need to know what's natural and what's a storm from the sun, and to be able to distinguish it. So there's a whole group to essentially characterize what the natural space environment was. And so that's how I ended up there. And one of my postdoc mentors, Michelle Thompson, introduced me to a new type of instrument in a new region. And so that's where I then figured out my research style. I'm very interested in a lot of different things. And so I'm happy to dive into a new problem, a new region. And so I've studied not only the magnetosphere, but the ionosphere and the region around the sun, the heliosphere, and how they all interact, recognizing that the space environment is a big system and all the different regions interact with each other very complexly. And so it's been a fascinating problem to try to detangle. And so over my career, I've been trying to figure out ways of developing technology so we could make observations in different regions simultaneously. And one of the problems with space science is it's expensive to launch a rocket and to build a satellite, usually hundreds of millions of dollars, many hundreds of millions of dollars. And so it's a big effort to lower the cost of access to space, and the commercial space industry like SpaceX and Jeff Bezos, Blue Origins, and others have attempted to reuse rocket components to lower the cost. And we just had a Virgin Galactic flight earlier this week or last weekend that has a different way to have a space plane take the rocket high up and then launch it. So the cost of doing space research is coming down, and now we're trying to reduce the cost of instrumentation. So that's what I've been doing at University of Michigan, is trying to build very low cost sensors.